We are here in this video to discuss key features of the graphs of absolute value functions. So you should have had in a previous unit learned how to graph an absolute value function using a table. Once you have the graph of the absolute value function, it's important that we can recognize our key features of the graph, which we'll see listed here on the left. The first is whether or not the vertex is a minimum or a maximum. So when we're looking at this graph, the vertex here is the top or the bottom of the V shape, depending on which way your function is opening. So if we have an absolute value graph that opens this way, our vertex is at the bottom. And here the vertex is at the top. When the vertex is at the bottom, we call that a minimum point. And when the vertex is at the top, we call that a maximum point. In other words, if the V opens up, the vertex is a minimum, and if the V opens down, the vertex is a maximum. So here, the vertex is a maximum, and we just have to write in our table that we have a maximum. The vertex itself we want to list as an ordered pair, so an x and a y coordinate. The blue point I labeled here is the vertex, and that has an x coordinate of -4 and a y coordinate of -3. The axis of symmetry is the line that would divide this absolute value function exactly in half so that it could fold over on itself and match up perfectly. So our axis of symmetry is always x equals, and it has to be the x value of the vertex. So if your x value of your vertex was -4, your axis of symmetry should be x equals -4. The domain, we always want to think left to right. Okay, and when I say left to right, we're talking about x values. So when we look at this graph, going in the direction of the left x values, the graph is continuing on forever, which means that the furthest value to the left would be -infinity. On the right-hand side, we also have an arrow that's showing that our absolute value graph would continue, meaning that the x values would continue going right all the way to +infinity. The range, we want to think y. Range goes low y value to high y value. Because this V shape opens down, our lowest y value is going all the way down, continuing to -infinity. Your highest y value is where the graph stops at the top and the y value that's there. So you'll notice this is the highest point on our graph. If I were to climb this graph, I'd be standing at the top when the y value is -3. And we're going to use a bracket because there's a closed circle up here at -3. Increasing and decreasing intervals. So I like to remind you that infinity is going to be on this side of your graph if you continued counting. -infinity would be on this part of your graph if you continued counting. -infinity for the y values would be in this direction. So when we're talking about increasing and decreasing, we're talking about intervals of x. So when we're talking about intervals of x here, increasing would be where my graph is going up from left to right. So when I'm looking at my graph from left to right, this section is where it would be going up. Okay, I need to name the x values that are covered in this section of the graph. If I look all the way to the left, I would say it's at -infinity. And then it stops at my axis of symmetry here. This is where the graph changes from increasing to decreasing. So we are going to stop at the point -4. For decreasing, intervals. We are going to say it's where the graph is going down from left to right. So that's the green portion of the graph here. The green portion of this graph, the x values start at -4 and go all the way to infinity. The y-intercept. The y-intercept is where the graph crosses the y-axis. If we can't see where the graph crosses the y-axis, then to get the y-intercept, we would have to put 0 into the original function. So in my original function here, anywhere I see an x, I would have to put a 0. So I would do 0 plus 4 is 4. Since it's the absolute value of 4, I'm going to keep it positive, but the negative on the outside turns it back to a -4. And then I subtract 3 to get -7. So if you don't have a y-intercept that you can clearly see on the graph, you need to substitute 0 in for x to figure out what the y-intercept is. Rate of change. Rate of change is another word for slope between these values. So I'm going to put a dot on -6, and I'm going to put a dot where x is -4, and I'm going to count the slope between those 2 points using rise over run, or change in y over change in x. So if I count from this first point, I'd have to go up 2 units, and to the right 2 units, which is a rate of change of 1. If I put points on -3 and -1, to get the slope, I would do the change in y over the change in x, or rise over run, which means I'd have to go down 2 and to the right 2, which simplifies to -1. Okay, that's it for all of the characteristics. I'm going to quickly go through another example because it looks a little bit different down here, but I'm not going to explain everything as thoroughly as I did in this one. So this graph, because the vertex is at a low point, we're going to call that a minimum. The vertex is at the ordered pair 2, 3. The axis of symmetry is the equation of the line that passes through the center of that absolute value function. So x equals, and it should match the x value of your vertex. The domain, you're going to start to catch on that the domain of the absolute value functions that we're looking at, because they're continuing to the left and to the right the entire time, is -infinity to infinity. The range goes low y value to high y value. So I start at the vertex, which is the lowest point on this graph, has a y value of 3, and goes up to infinity. The arrows tells me it's going up forever, positive infinity. Intervals of increase and decrease. I like to put -infinity on this side, positive infinity here, and then note that we are crossing or changing at 2. So if I want where the graph is increasing from left to right, that's here in yellow. If I want where the graph is decreasing from left to right, that would be here in green. Okay, we read graphs left to right. So where it's increasing, the yellow portion starts at 2 and goes on to infinity. The green portion, if I look all the way to the left, would start at -infinity and stop at 2. The rate of change, or excuse me, the y-intercept, again, I can't see the y-intercept, so I'm going to replace x with 0. So I get the absolute value of 2, -2, which turns into a +2. And when I multiply that by 3, I get 6 plus 3, so 9. So my y-intercept is 0, 9. Now remember, if I could see that from the graph, it would be a much easier question. Rate of change, the slope between 2 and 4. So I would go up 3 and over 1. So my change in y is 3, my change in x is 1. For 0 to 1, if I start at the point at 0, which I can't see here, and 1, so we know that the ordered pair is at 0, 9, and then at 1, we're at 1, comma 6. So our change in y is -3, we're going down 3, and our change in x is +1.